Imagine, imagine a hospital room. You've got an algorithmic model processing like 10 million data points a second, and it tells the surgeon to operate.
Right, immediately.
Yeah, but the surgeon, who has maybe 20 years of instinct and notices just this subtle irregularity in the patient's breathing, says to wait.
hmm
So if they wait and the patient tragically dies, who gets sued?
That is the million-dollar question.
Right. Is it the hospital? Is it the doctor? Or is it like the software developer who actually wrote the code?
Exactly.
Welcome to today's Deep Dive. I am so thrilled you could join us today because we are unpacking a highly concentrated tech news digest from May 24th, 2026.
And there is a lot to unpack.
There really is. And the biggest takeaway here isn't just that artificial intelligence has become, flawless or magical.
Far from it.
Right. It's that as these systems get closer to perfection, humanity itself is rapidly becoming the bottleneck.
That is such a great way to put it.
So for you listening, our mission today is to skip the usual hype cycle. We want to extract the actual so what of how this technology is fundamentally rewiring our healthcare, our education, and our global environment.
Yes, because every single major leap forward we're seeing in these sources is instantly slamming into a very human roadblock.
So to set the stage here, what exactly is the defining characteristic of this current era? Because it feels different.
It does, and that tension is really the defining characteristic. If you look closely at the data we are dissecting today, a very distinct pattern emerges.
Okay, what kind of pattern?
Well, we have completely transitioned away from the era where an AI was just a passive tool.
Like a search engine.
Right, exactly. Something you just query and wait for an answer. We are now living in a reality where these systems operate autonomously.
And that changes everything.
It forces a constant, really high-stakes negotiation between the mathematical certainty of the machine and the inherent messiness of human intuition.
The messy human reality.
Yeah. It is no longer a question of what the architecture can calculate. The dominant question now is how we actually integrate those calculations into our physical world.
Which brings us right to healthcare, where the stakes of that integration are incredibly personal for all of us.
Absolutely.
The May updates from the source material detail just an absolute revolution in diagnostic tools, specifically in pathology and radiology.
Is massive.
But we aren't just talking about a digital magnifying glass here. Okay, let's unpack this. To understand the shift, you really have to look at the mechanism.
Right.
So a human radiologist, even a brilliant one, is essentially down on the ground inspecting individual trees in a forest.
Looking at the bark, the leaves.
Exactly. They're looking at the shape of a cluster of cells, analyzing the texture, trying to spot a pattern they memorized back in med school. But the systems currently being deployed in major research hospitals operate completely differently. They are like satellites in orbit.
That's a really good analogy.
Thanks. I mean, the algorithm doesn't actually know what a cell is, right?
No, it has no biological concept of it.
Right. But it can perfectly detect the invisible mathematical heat signature of a pathology spreading through a tissue sample across, like, tens of thousands of dimensions instantly.
What's fascinating here is that it's a fundamental difference in how information is processed. Human doctors, they're prone to fatigue errors.
Of course, they're human.
Right. If a radiologist is at the end of a 14-hour shift, their eyes just physically struggle to detect a microscopic anomaly on a scan.
Yeah, I'd be blurry-eyed after hour 3.
Exactly. But the machine does not experience fatigue. It analyzes the 10,000th scan with the exact same mathematical rigor as the very first one.
Wow.
And the numbers coming out of these recent clinical deployments show these models are identifying markers for diseases long before they manifest any physical symptoms.
Before a human eye could ever catch it.
Exactly. The ultimate operational goal here is to shift the entire medical paradigm from reactive treatment to proactive, hyper-personalized intervention.
Okay, I see the logic there, but let's test that against the reality of a modern hospital.
Let's do it.
Because this brings us right back to that operating room scenario I mentioned at the top of the show.
The liability question.
Yeah. The tech industry loves to push this seamless utopian narrative where the machine just prints out the right answer and everyone goes home happy.
If only it were that simple.
Right. But if the algorithm's diagnostic accuracy actually surpasses the human expert, who really makes the final call when they disagree?
That is the friction point.
If the satellite says the forest is on fire, but the guy on the ground doesn't smell smoke, who holds the liability when things go wrong?
Right.
We can't just pretend the legal friction doesn't exist.
No, we can't. And honestly, The liability issue is the primary bottleneck preventing blanket adoption right now,
Really? Not the tech itself.
not the tech. And the medical community is actively restructuring how they handle this. From a malpractice perspective, you are seeing a shift toward what they call a human-in-the-loop legal framework.
Human in the loop. Okay, what does that mean in practice?
It means the algorithm is legally classified as a diagnostic partner.
Oh, like a second opinion.
Exactly, an ultra-sophisticated second opinion. But the attending physician must sign off on the final treatment plan.
Okay, so the doctor's still on the hook.
Yes. If the doctor blindly follows an algorithmic recommendation that leads to harm, the liability still largely falls on the human for failing to, validate the output against their own clinical judgment.
Wow. Talk about pressure.
But, and this is a big but, if the algorithm is proven to have a systemic flaw in its training data, that liability can aggressively shift back to the developers.
Which opens up a massive logistical nightmare regarding that training data.
Oh, absolutely.
Because to build a model that can predict a pathology before it happens, you have to feed it millions of highly detailed, intimately personal patient records.
You need mountains of data.
You can't train the satellite without the raw geographic data.
Exactly. And hospitals are justifiably terrified of centralized data breaches.
Oh yeah, you can't just pool the global health records of millions of people into a single server. That's a hacker's dream.
Right. So the technical workaround being deployed right now is called federated learning.
Federated learned.
Yeah. Instead of moving the sensitive patient data up to the central algorithm, developers are actually sending the algorithm down to the localized hospital servers.
Oh wait, so the data never leaves the hospital.
Exactly. The model trains locally on the encrypted patient data, learns the new patterns, and then only the updated mathematical weights.
Not the actual patient file.
Right, just the math. Only that is sent back to the central hub.
That's brilliant.
It's an ingenious way to overcome the privacy roadblock while still achieving that massive scale of pattern recognition.
But even with secure data, there is still the problem of the black box.
Yes, the explainability problem.
Right. The algorithm gives a diagnosis, but it doesn't always explain its work. It just says, here's the answer.
And that is why extensive validation is the major buzzword across these recent deployments. In medicine, statistical success just isn't enough.
You need to know why.
You need mechanistic understanding. If an AI identifies a high risk of cardiac failure, the clinician needs to know why.
Are we looking at arterial density, or did it just latch onto some irrelevant artifact in the scan?
It's like the type of machine used to take the image. That actually happens.
Wow, really?
Yeah. So developers are now being forced to build explainability protocols directly into the architecture.
So forcing the algorithm to show its math.
Essentially, yes. Forcing it to translate its multidimensional math back into biological markers that a human doctor can actually verify.
So it's this constant, rigorous translation between machine logic and human physiology.
Precisely.
Okay, so we've figured out how to map the physical anomalies in our cells with astonishing precision. But what is wild to me is that developers are now taking that exact same pattern recognition architecture and pointing it at something much messier.
Human cognition.
Yes. The developments in the education sector show this complete leap. We are moving from biological diagnostics straight into intellectual diagnostics.
The architecture is surprisingly translatable, which is fascinating.
Really?
Yeah. Instead of analyzing pixel density on a lung scan, the models are ingesting behavioral data points to map a student's cognitive landscape.
And the granularity of that tracking is intense.
It is.
Here's where it gets really interesting. We aren't just talking about an app that gives you a harder math problem if you get the previous one right.
No, it's way beyond that.
Schools and universities are deploying systems that measure microinteractions.
Mm-hmm.
The algorithm tracks how long your cursor hovers over a multiple-choice answer.
Mm-hmm.
It measures your keystroke cadence to gauge hesitation. It maps exactly where your attention fragments.
It's constantly watching.
By aggregating all of those tiny behavioral tells, the system constructs a real-time, highly individualized knowledge graph for every single student. So it instantly identifies that a student isn't struggling with the core concept of algebra, but specifically with the working memory load of holding fractions in their head.
It pinpoints the exact bottleneck.
Exactly. And then it subtly rewrites the curriculum to adapt to that precise issue, while simultaneously feeding advanced, accelerated modules to a student sitting at the very next desk.
It is the absolute destruction of the traditional one-size-fits-all standardized curriculum.
It's crazy.
But from a purely cognitive efficiency standpoint, it is a brilliant application of the
I
technology.
mean, sure, it sounds incredibly efficient.
Because the legacy model of education has always suffered from this unavoidable inefficiency of teaching to the middle of the bell curve.
Right, the average.
Yeah. In a room of 30 students, the curriculum is moving too slowly for the top tier and too quickly for the bottom tier.
So half the class is bored, and the other half is lost.
Exactly. By deploying a hyper-personalized, dynamically adjusting curriculum, you are theoretically keeping every single brain in a state of optimal cognitive flow. No one gets bored, and no one gets irreparably left behind.
I understand the efficiency argument. I really do. It's like having this omniscient, infinitely patient tutor hovering over your shoulder, constantly adjusting the difficulty dial of your life so you never hit a wall.
It sounds ideal.
But that lack of a wall is exactly what worries me. And the source material points this out too, warning about the loss of the human touch and interpersonal skills.
That's a very valid concern.
Right. If a student's entire educational journey seamlessly adapts to their specific quirks, their reading speed, their specific frustration triggers, without them ever experiencing any friction,
They're in for a shock.
they're going to hit a massive wall the second they graduate. By perfectly adapting the environment to the brain, aren't we inadvertently training the brain out of neuroplasticity?
You're hitting on the core debate right now.
Because the real world is a messy, unstructured, untailored environment. It doesn't automatically drop the reading level of a complex legal contract just because you are feeling overwhelmed.
No, it doesn't. And that is the core neurological anxiety driving the current debate among educators. You are touching on the concept of productive struggle.
Productive struggle.
Yeah. In developmental psychology, cognitive friction isn't a bug in the learning process. It is the fundamental mechanism of growth.
So we need the friction.
We do.
Well,
When a student encounters a problem they cannot immediately solve, the resulting frustration actually forces the brain to forge new neural pathways.
oh wow.
If an algorithm preemptively smooths out every conceptual bump in the road before the student even registers the difficulty, you run the risk of creating a generation of learners who possess vast amounts of optimized knowledge, but zero cognitive resilience.
It's like living your entire childhood in a hyperbaric, perfectly climate-controlled chamber.
That's exactly it.
The second you step outside, your immune system doesn't know how to handle a common cold. The friction of the traditional classroom, having to raise your hand, feeling embarrassed when you get something wrong in front of your peers, having to collaborate with a classmate whose learning style just totally clashes with yours, that is where socialization and grit are actually forged.
Which is why the developers behind these educational models are now being pushed to engineer synthetic friction back into the algorithms.
Wait, synthetic friction?
Yes. It is a fascinating paradox. They spent years building systems designed to eliminate educational bottlenecks, and now they are actively programming the software to occasionally step back and just let the student flounder.
You're kidding. They purposefully make it harder.
Yes, the models are learning to recognize the optimal threshold of frustration. They push a student right to the edge of giving up, forcing them to develop problem-solving stamina before intervening.
That is an incredibly delicate balance.
It is. The goal is no longer just knowledge acquisition. Developers and educators are in a continuous dialogue to ensure it's about the careful cultivation of intellectual endurance.
We're seeing this pattern constantly today. The technology is brilliant enough to optimize the system, but the human necessity for struggle, for context, and for resilience forces us to, pull back the throttle and negotiate the implementation.
We always end up being the friction.
Exactly. And if you think mapping the cognition of a single student is complex, we need to drastically zoom out now.
Let's look at the macro.
Right. What happens when you apply this exact same high-fidelity pattern recognition to the entire planet? The third major domain in our deep dive today looks at how AI is being deployed as a macro diagnostic tool for climate change and environmental degradation.
And if we connect this to the bigger picture, the sheer scale of the variables involved in atmospheric and ecological modeling is something the human brain has historically struggled to synthesize.
Even with supercomputers, right?
Even with traditional supercomputers. The global climate is the ultimate chaotic system. It is the perfect arena for massive-scale machine learning.
Well, the sources show an incredible shift in how we manage the power grid. These models aren't just reacting to power outages anymore, they are engaging in highly complex predictive load balancing.
Anticipating the need before it happens.
Exactly. The AI ingests decades of localized meteorological data, real-time satellite imagery, and socioeconomic usage patterns. It can predict a massive, anomalous heat wave in a specific region 3 days before it hits.
Mhm.
It then proactively reroutes excess energy from, say, a high-yield wind farm in the Midwest directly into the cooling centers of a coastal city, perfectly balancing the grid before the demand spike even occurs.
It minimizes waste on an unprecedented scale.
It really does. And beyond the grid, there's also a massive surge in startups utilizing AI to track Scope 3 emissions in real time to hit sustainability goals.
Which is notoriously difficult to track.
Right. They're analyzing global shipping routes, supply chain bottlenecks, and even localized methane leaks from agriculture, translating abstract carbon accounting into dynamic minute-by-minute metrics.
Moving from retrospective data to real-time tracking is a monumental paradigm shift. Historically, our approach to climate metrics has been almost entirely autopsy-based.
Autopsy-based, meaning looking at it after the fact.
Exactly. A government agency releases a report detailing how badly a country missed its emissions targets 2 years after the fact.
Which is pretty useless for actually fixing the problem in the moment.
Exactly. Real-time, localized tracking strips away the abstraction. When an AI can pinpoint a specific leaking industrial valve in real time using satellite infrared data, it turns a vague global crisis into an immediate, actionable, localized event.
So what does this all mean? Because having the actionable data is really only half the battle.
It is.
To put this in perspective, having an AI map out our global carbon emissions and optimize our power grids, it's essentially like outfitting the entire planet with a hyper-advanced fitness tracker.
I like that analogy.
The data on the screen is flawless, right? It tells you exactly how many calories you're consuming, how elevated your resting heart rate is, and it maps out the perfect, scientifically rigorous workout plan to save your life.
What?
But the fitness tracker cannot do the push-ups for you.
No, it cannot.
You still have to get on the floor and sweat.
Mm.
And the underlying warning across all these environmental dispatches is that execution will require careful consideration.
Which is a polite way of saying it's going to be really hard.
Right. It requires immense political and economic friction. The algorithm can perfectly model how to decommission a legacy coal plant and replace it with a decentralized renewable grid. But the algorithm cannot force a stubborn human executive to shut down their most profitable asset.
And it can't force a government to rewrite its zoning laws. That execution gap is the most dangerous aspect of the current climate technology landscape. AI is undeniably the ultimate analytical engine. It can diagnose the sickness of the planet and write a flawless prescription.
Well, we have to actually take the medicine.
Yes. We have to heavily scrutinize how we deploy these metrics. There is a very real documented phenomenon where institutions use sophisticated AI tracking merely as a form of high-tech greenwashing.
Oh, wow. High-tech greenwashing.
Yeah. They generate incredibly detailed, beautiful dashboards of their environmental metrics, which creates the illusion of progress without ever actually fundamentally changing their operational behavior.
So they just point to the dashboard and say, look, we're tracking it.
Exactly. It is seductive to celebrate a perfectly optimized predictive climate model. It makes us feel like the problem is solved. But generating the insight is easy. Summoning the geopolitical courage to actually execute the model's recommendations is incredibly difficult.
The AI gives us the map, but humanity still has to actually walk the path.
We do.
Which brings us to the core synthesis of this entire discussion. Let's zoom out for a second and look at the connective tissue across all three of these domains.
It all ties together.
It really does.
Right.
Whether you are in a sterile hospital room, a middle school math class, or looking at the Earth's atmosphere, the underlying reality is identical. AI is no longer just a buzzword.
No, it's a transformative force.
We have successfully built the ultimate diagnostic engine. It can find the invisible disease in our biology, it can map the inefficiencies in our intellect, and it can predict the collapse of our ecology.
But the technology alone is entirely inert.
Right. The success of this era relies 100% on the ongoing, incredibly messy dialogue between the mathematical precision of the machine and the chaotic, necessary friction of human judgment.
It forces a mirror up to our own systems. The algorithm inherently seeks optimization, but human societies are built on things that resist optimization.
Like what?
Things like empathy, tradition, and, as we discussed with education, the necessity of struggle. The friction between the tool and the user isn't a failure of the technology. It is the essential guardrail that prevents us from turning complex human lives into cold data points.
And that tension leads me to a final concept I want to leave you with today.
Yeah.
Just something to mull over as you watch these technologies roll out in your own life.
Okay.
We've seen that AI is unparalleled at analyzing our data to show us exactly where our systems are failing.
Yes.
But if the machine is becoming this adept at diagnosing our specific vulnerabilities, how long until we ask it to analyze our collective societal behavior?
Oh, that's a huge thought.
Think about it. If we feed the algorithm our economic realities, our political gridlock, and our resource constraints, and it tells us mathematically that we only have the capital to either fix the education system or stabilize the climate grid,
Forcing us to choose.
do we blindly follow the optimized logic of the machine, or do we trust our own flawed, messy human priorities to make that final call?
That shifts the paradigm entirely. Once you allow an algorithm to not just execute a task, but to define the moral priority of the tasks themselves, you are fundamentally altering the architecture of human governance.
I have a feeling that exact debate will be dominating the news cycle sooner rather than later.
I wouldn't be surprised at all.
Thank you so much for joining us on this deep dive today. We hope we helped you cut through the noise, understand the actual mechanisms at play, and find the real insights hidden in the data.
It's been a great discussion.
Keep questioning the information around you. Always look for that human element pushing back against the algorithm, and we will catch you next time.